Hello and welcome to this short guide to choosing the right Ensenso B camera. My name is Ute Seitz. I'm working with IDS in the 3D machine vision consulting, and I will share you some informations about our first Ensenso camera that is available either with monochrome or with color sensors. First, we'll have a look at the technology differences. Then I will share with you some application notes that are interesting for those of you who will combine color with 3D data. So let's have a look at the used stereo sensors inside the B57 series. On the right side, you see what you already know from other Ensenso cameras. This is the sensor covered with a bandpass filter that allows only the blue light coming from the projector to pass the filter and hit the camera sensor. On the left side, you see the Bayer pattern that is applied to the sensor for the color images. So this is the difference between color and monochrome B57. Let's look how this transfers into image quality. On the left side, you see an image taken with the color version. So you can see a slightly green color in the image. And you can see that is slightly more blurred than the right image that is taken from the monochrome version of the B57. This is because of having no bandpass filter. The sensor is more, the ambient light comes more into the sensor than when using the bandpass filter. This is also visible when we have a look in the datasheet and compare the set accuracy of both cameras. You see the values in 350 millimeters distance. This is the focus distance of the camera. And in 800 millimeter distance, this is the maximum distance for the color version. So you see that the monochrome version, the set accuracy is better by a factor of about 1.5. This is data taken from the backside of a calibration target. Then I did a plane fit and measured the distances of the 3D points to the fitted plane. So with the monochrome version, you can see the 1 sigma, the standard deviation is 0.6 millimeters. And in the datasheet at this distance, we have 0.65, which is very close. Using the color camera, we have the standard deviation sigma value of 0.96. This is also close to the datasheet that is 0.98 at this distance. This is the reason why the color camera is only available for shorter distances, because the set accuracy will become worse in larger distances. So it's recommended to be used only in a distance range from 210 to 800 millimeters, whilst the monochrome version can be used up to 2 meter distance. The focus distance is same for both models. It's at 350 millimeters. Then we have another parameter that changes by using color sensors. The color version has a 3-channel image, RGB, and the stereo matching algorithm has to look at all of the image channels. So the stereo matching takes a little bit longer, and this transfers into the frame rate. So you can see if you're using single shot, then the effect of the stereo matching is weighted more. Then you have a frame rate from 4.3 frames per second, point clouds per second for the color camera, and 6.1 for the monochrome camera. If you take more images by using flex viewer, the difference will be less, because most time is used for the image transfer from the camera to the computer. Now I will have a look at using the 3D data and combining it with the color images that are taken from the camera. You might have already seen the last video that showed how to do this using Ensenso C, for example. And now we will talk about the differences between using color data from an Ensenso C camera compared to color images coming from the Ensenso B. Let's have a closer look at the cameras. So the viewing position of the camera is the same in the Ensenso B because the color cameras are already the sensors for the stereo camera. Looking at the Ensenso C model, you can see that there is an additional color camera, so the viewing pose of the color image is not the same as the viewing pose for the 3D image, because this is the viewing pose of the left Ensenso stereo camera. This scenario shows what you might already know from adding color informations to any of the Ensenso cameras we provide. So it could be also an N series or a C series. You have the rectified left image. That is the viewing position of the left camera. This is the base data for the 3D image. And you have another image, that's the color image, that is taken from a different point of view. And so you have to render the 3D data into the sensor of the color camera, and this is done by using the command render point map. And then you use the render point map image to combine the 3D data with the color data. Render point map contains the 3D coordinates arranged in the same pixel grid as the color image. You can find this information in our other how-to video that is linked in the video comments. Now, looking at the B series, you can see that the left rectified image that is used for computing the 3D data is the same viewing position as the texture image that is on the right side in that slide. So you don't have to render the points to the color camera because it is already in the same pixel grid, and you just have to compute the point map to align the 3D data with the color data. Let's start with the common steps. For both cameras, you start with capturing the scene with the projector turned on to get the raw material for computing 3D data. This is the disparity map. Then you capture another image to get the color image. For the B series, you get basically the same image, just without the projector by turning the projector off. With the C series, you capture the color camera inside the C series. Then you have a color image from a different point of view. And so the next step for the B is compute point map. And for the C series, it's render point map. To summarize it, here are some points that you might consider when choosing your Ensenso B model. The first thing is the working distance. The B57 is designed for very short working distances, and if you want to go very close to your objects, the B57 is the model to go. The next thing is choose a B57 if your application requires a small and compact camera. If your application needs to use additional color information, you can choose the Ensenso B with the color sensors. If it's okay with the environmental lighting conditions, and your set accuracy will be within what you need. If you need more accuracy than you get with the B57, then choose an Ensenso C model. Another opportunity is you use the monochrome version of the B57 and add an additional color camera from our portfolio of 2D cameras. That's all for the slides now. If you have more questions, feel free to contact Machine Vision Consulting at IDS. You're welcome to send us your objects, and we can provide you sample data so you can choose for your application if the camera meets your requirements. Thank you for watching. Stay tuned. We are continuously uploading new content to our Vision channel that helps you with all topics in machine vision.